I will solve LeetCode question 2194. We are given a 2D integer array called descriptions. So it is a 2D array where each vector inside this array has three elements called parent, child, and is left, where parent of I indicates that it is parent of child, and then it says in a binary tree the third element of this vector is either 1 or 0. If it is 1, it means the child is left child. Otherwise, if it is 0, it means the child is the right child of the parent. We need to construct the binary tree as described and return it, and return the root. Root means the starting index. So a root is basically the parent of all, and a root is never a child. These two things should be remembered. We need to return the root. Okay, so let me show you. So we have got parent, child, and then comes is left. So initially it is 20, 15 and 1. So 20, 15 and 1. So it says 20 is the parent, 15 is the, over here it is the left child, since is left is true. So we have 15 as the left child. So we get, after processing this, now we have got 20, 17 and 0. So 20, 17 and 0. 20 is the parent and 17 is the child of it, and since is left is 0, it means it is the right child. So we have got 17 over here. We process the second element of this 2D vector or array. Now we have got 50, 20 and 1. So it says 50 is the parent of 20. So 20 is the child and 20 is the left child, since is left is 1. So 50 will be somewhere over here. So we completed this. Now it says 50, 80 and 0. 50, 80 and 0. So 80 is the child of 50 and it is on the right, since is left is 0. So we have 80 over here. Now our last element of this 2D array over here is 80, 19 and 1. So it says 19 is the child of 80, and however it is the left child. So we have got 19 over here. So this is the desired binary tree and we need to return the root. So over here 50 is the root. So we need to return the address of 50. So we return the address of 50. So I'll show you how to solve this. To solve this problem, we first have a map. So map is a key value pair. So my key over here will be the value of that element, that is the value of the tree node. So this is the tree node, and then my value is basically an address. And my second data structure that we will be using is a set. Okay, so this will store the children. Okay, so we have seen that the root can never be a child. So whatever element is not present in this set, that means it is a root, and we will return that. So let us go ahead. So we have got a parent, child, and then comes is left. So my first element over here is 20, 15 and 1. 20, 15 and 1. My first step is to go and check if 20 is present or already seen. So over here we go to the map, we ask is 20 there? So it says no. So our task first is to create 20, and let us assume we give it an address A. Okay, so we have got 20 and the address is A. My second step is to see if the child is already present. We go to the map and check if 15 is already present. It is not present. So we put 15 and we give it an address B. So we have got 15 with an address B. Since this is the left child, we put the pointer like this. That is, the left child of 20 is 15. Now let us go ahead. And since 15 is the 15, we have seen it as a child, we put this in the set. So we have 15 in this set. Now my task again is, we got parent as 20 and then child as 17 and is left as false. So we go and check is if 20 is already seen. It says yes at A. So we go to A and then we go for 17. So it says 17 is not there in the map. So we give it an address C and it is on the right of 20. So we have this, 17 over here with an address C to the right of A. Since it occurs at child, we put this in the children set. Now my third element is 50, 20 and 1. 50, 20 and 1. I go and check if the parent is there in my map. So it is not there. We give it an address D, and then we have got 20. So yes, 20 is present at address A. So our task is basically, now this is on the left. So 20 is on the left of 50. So we put 50 and on the, with an address D, and then 20 goes to the left of 50. Since 20 is the child, we put in the child set, so we put 20. Next we go ahead with 50, 80 and 0. So we got 50, 80 and 0. So we go and ask if 50 is present in the map. It says yes at location D. Okay, so now we go and ask if 80 is present. So 80 is not present, so we create 80 with the location E, and 80 is on the right of 50. Okay, so this is 80 with the location E on the right of 50, and since 80 is seen as a child, we put it in the children set. Okay, now we go ahead, we got 80, 19 and 1. So 80, 19 and 1. So we go and ask if 80 got an address. So it says yes at E. So and then we ask if 19 is already present in the map. It says no. So we go and give it an address F, and 19 is the left child of E. So we have got 19 over here as the left child of E. Since 19 occurred in the children's 19 occurred as a child, we put it in the children's set. So over here, this is my desired binary tree, and we need to return this element from here, the address of this. So now we traverse again on all these elements. So this is the parent, this is the parent, this is the parent. So if a parent is a child, it means it is not a root node. So we go and check, is 20 the root node? It says it is present in the children set, so it is not a root node. Now we got again 20, so we see it is present in the children set, so it is not the root node. Now we go and see 50, so 50 is not present in the children set, so it is the parent of all, so we return 50. That is the address of this. Okay, now I will code in Rust. So our first task is basically to create a map. So I say let mutable, the name being MP. So this is a hash map, so integer of type 32, and over here we use RC, that is reference counted, for multiple owners of a node, and then we take a reference cell, that is mutable nodes after creation. So this is tree node. So this is hash map new, followed by, now we create the children set. So over here it will be let mutable, we call this as children, and this is a hash set, so it contains integers of type 32. So we create a new set. So now we start iterating over the descriptions. So we say for v in, so we copy this description. So we find the parent. So let parent is equal to the first element, that is v of 0, followed by let child is equal to the second element, that is v of 1, and this is left is the third element, that is v of 2. Okay, so now if my map does not contain, this p, so what we do is create, so this is inserted into the map. So we insert p followed by the address or the reference. So this is reference cell new, and then comes tree node. So we create a new tree node. Okay, and similarly we do the same thing for the child. So if the child does not exist in the map, we say if the child does not exist in the map, we take the child, we insert the child over here. Okay, so now we get the node. Our next task is, so we create a parent. So let parent is equal to mp.get. so this p, we unwrap it and then clone it. So over here we get the node stored at key p, so we assume that it exists, and then it creates another RC pointer to the same node. Similarly we do this same step, so we do the same step for the child. So we put child, and we put C over here. Okay, so now if this is a left child, so if my left is equal to 1, that means this is the left child. So we do parents dot borrow mutable, we assign it to the left. Okay, otherwise it is present on the right, so we take the parent and then to the right of it we put the child. So this is right over here, and then since we have found a child in the children set, we insert this child C. Okay, now after coming out from this for loop, we need to check, we need to find the root node. So for description, in descriptions, sorry, so we do this, so we get the parent. So let P is the first element of this vector, that is we had initially the 2D, so we get this 1D. Now we take the children and we find whether this children set contains this P. So if it does not contain, it means we have found the root node, so we return the address of it. So we do mp.get, we take the map and get the address of this, unwrap it, and then clone. So after coming out, so at each case we'll be able to successfully find a root node. However, we just write it none for the sake of running the code. Okay, so since we have used set and hash map, so we use standard colon collections. So this is hash map followed by hash set. Now let me submit this. So over here sorry, these are the wrong brackets. So we get error over here. So if this is left, so we do parent dot borrow mutable and the left of it some child. So this is parent dot borrow, sorry, this would be underscore mutable, and this is also underscore mutable. So this would be mp dot, over here it is contains, not contain,